What's up, engineers, and welcome back to the CMTEQ Electrical Engineering Quiz Review, where we basically break down the toughest questions and sharpen your skills. Today's power pack lineup features DAC design, as you can see here, power system stability, and electrical wiring regulation. So make sure you stick around because you might just learn the trick that will help you ace your next electrical engineering test. And if you miss our previous episode, no problem, there is a link in the description box. The first question is related to the design of a digital to analog converters, also known as DAC. The question is, what is the role of the RC filter in creating a DAC from a PWM signal? And the provided options are 1. To amplify the PWM signal, 2. To increase the frequency of the PWM signal, 3. To convert the analog signal back to a digital signal, 4. To smooth the PWM signal into a more constant DC voltage. Great. Now, before you make your choice, we've got an illustration here where you've got your Arduino or controller outputting a PWM signal. There is your RC low pass filter, and you've got your DC output voltage here. So what is your choice? Okay, let's go ahead and reveal how the community voted in the next 5 seconds. Great stuff. The community voted overwhelmingly for option 4, that is to smooth the PWM signal into a more constant DC voltage. But is this the correct answer? Let's go ahead and reveal the correct answer. Correct. So this is the right answer. But now, why is this the correct answer? Well, the question is very simple. Is because the RC filter here act as a low pass filter, okay? Because the switching frequency coming from your controller here have a frequency component in it, then your RC filter low pass will basically cut off that frequency and smooth out your output voltage, basically averaging it out to a more constant DC voltage. Now this is very good because the smoothing effect is crucial for converting the PWM signal into a analog or constant DC voltage. But then there was a question from the comment section of this particular quiz that asked, is there any advantage between this particular kind of a PWM digital to analog converter setup to a resistor ladder setup? Now, clearly, this looks much simpler to me, okay? Because I only have a microcontroller here and an RC filter, okay? Now, if I want to make this from 0 to 10, because right now I'm limited to 0 to 5, because that will be the voltage, the maximum voltage from the Arduino, but if I want to go from 0 to 10, obviously I've got a tutorial that I've linked that you can then add an operational amplifier in a non-inverting mode to basically buffer your voltage up to 10 volt, okay? But in a resistor ladder network, you've got a bunch of resistors that are interconnected and an op-amp. Now, in that systems, it's much complicated, right? Because you rely on precision resistance tolerance. So you can't put the 20%, 10%. You need 5 or 1% precision resistance. And if the connections goes wrong, then you've got problems, and the control of that systems is pretty much hardware. But over here, you can change your PWM frequency or resolution or duty cycle to basically just smooth out or control whatever you want on your DAC. So you've got more flexibility in this system. Hence, these are more advantage. Great stuff. Now let's go ahead and move on to the next question. And the next question is related to the earth wires on overhead transmission line, as you can see in the illustration here. So I'm sure you've come across the transmission line system where you've got a 5 wire systems, 3 lives, line 1, line 2, line 3, and the neutral wire, and you've got a 4th wire there which is the earth or ground wire, way at the top of every other wires, right? Now, why is it the case? Why are earth wires run above the live conductors of overhead lines? That's the question. And the provided choices are: 1. Reduce electromagnetic interference. 2. To improve power efficiency. 3. To enhance safety. So what do you think is the correct answer? Before you give your answer, let's go ahead and reveal how the community voted. Great stuff. The community voted for option 3, to enhance safety. Now, if you chose number 3, you are correct. However, there is about 19% that went for option 2, to reduce electromagnetic interference. But now, is this the correct answer? Let's reveal the correct answer. Great stuff. This is indeed the correct answer. But why is it the correct answer? Because earth wires, as I've said earlier, they run above, as you can see here, obviously to enhance safety. Now, why is this position? Now, this position basically helps in protecting the live conductors, okay, from lightning strike and reduce the risk of electrical fault. So, when the lightning strike is going to come from above, before it get to the three-phase lines here, it's going to first get that earth. And as the lightning intentions is not to get to those wires, the lightning wants to get to the ground. Okay, so by placing that earth wire above, you providing the lightning with the shortest path to ground, so it doesn't have to find the ground here. You can just get it there and straight to the ground. So in a sense, the reason why you've got that wire there is to enhance safety and provide a safest or quickest discharge path for the lightning. That is the correct answer, thereby reducing the risk of electrical fire. Now let's move on to the next question. Now, just a quick friendly reminder that if you find these quizzes useful, you find value in them, please make sure you give it a thumbs up and subscribe to CMTEQ channel so that you don't miss the next quiz review. And you are also more than welcome to share it to your social media network. I very much appreciate your support. Thank you very much. And the next question is related to grid stability through the DR, or demand response. So the question is, how can demand side resources support frequency stability in the grid? Okay, now demand side responses is basically the grid's ability to interact with consumers so that it can better address the energy demand from the consumers. Now, how can those resources better support frequency stability in the grid? So that's the question. And the provided options are: number 1, by always increasing their load. Number 2, by reducing or shifting loads during frequency deviations. And number 3, by maintaining a constant power factor. And lastly, number 4, by supplying DC power to the grid. That sounds very interesting one. Now, what is the correct option here? Now, before you reveal your answer, let's go ahead and reveal how the community voted for this particular multi-choice question. Great stuff. The community voted for option 2, by reducing or shifting loads during frequency deviations. There is a 28% that went for option by maintaining a constant power factor. That's interesting. So, how can demand side resource support frequency stability in the grid? The majority think it's by reducing or shifting loads during frequency deviations. Now, is this the correct answer? Let's go ahead and reveal the correct answer. Great. So correct. So this is the correct answer. But why is this the correct answer? Let's go ahead and elaborate. Simply put, the demand response, or DR. It's very crucial for grid stability and managing the smart grid system. So this program basically allow large aggregated consumers, people who need lots of power, okay, to reduce load during under frequency events, okay, when those things happen. So this basically help the grids in terms of rebalancing the supply demand without regenerating or adding additional generation into the grid. So it's basically a cost effective decentralized solutions that improve grid flexibility and reduce the need for spinning the generators harder using the reserves in the modern grid. So that's basically how the demand side resource or the DR system help manage the grid stability by constantly interacting with the consumers to ensure that whether it's for frequency stability or just trying to flatten the peaks demand when it happens. Great. Now let's move on to the next question. And this particular question is related to the NFPA 70 NEC, National Electric Code for the United States. Now this is for our viewers in the US. Now, what is the main focus of the National Electrical Code, NEC? That's a question. And the provided options for these particular questions are: number one, to provide guidelines for the manufacturing of electrical appliances. That sounds maybe the answer. Number two, to regulate the use of electricity in industrial processes. Number three, to promote energy conservation in residential buildings. Okay, another potential answer. Number four, to ensure the safety installations of electrical wiring and equipment in the United States, in the USA. Okay, now, just before you reveal your answer to us, let's see how the community voted for this particular quiz. Great stuff. The overwhelming majority went for option 4. They say that the main focus of the National Electrical Code in the US is to ensure the safe installations of electrical wiring and equipment in the USA. This seems to be the correct answer, but is it the correct answer though? Let's go ahead and reveal. Indeed, it is the correct answer. Now let's concur that this is the correct answer and just elaborate a bit on this book, the NEC, the standard. Okay, so what does it entail? So basically, the National Electrical Code in the USA, which is officially designated as NFPA 70, it is a widely adopted standard in the US that basically sets the minimum requirement for safe electrical design and installations, inspections, to basically protect the people and property from electrical hazard when the installations are being carried out. So it basically covers all aspects of electrical system that you can think of in residential, commercial, and industrial settings, also including not limited to wiring methods, grounding, overcurrent protections, equipment installations, and obviously special occupancies setups as well. Now, by establishing the uniform safety practices, right, like the next here, it's basically help prevent electrical fires, shocks, arc flashes, and other dangers that can happen because of wrong electrical wiring. Okay, therefore it's actually allow the electrical system to operate reliably and safely throughout the entire lifespan of those systems. So this is synonym or similar to the compliance standard that we have, like IEEE standards or IEC standard compliances and many other national compliance that we have for each specific country. Great. Now off to the last quiz review of the day, and this question is also related to electrical wiring standard, but this time around in the United Kingdom. And the question is, BS 7671 is also known by which name? Now, this is specifically for our viewers in the United Kingdom. The provided options or choices are: number 1, UK Electrical Code; number 2, the British Power Standards; number 3, Low Voltage Safety Guide; number 4, IET Wiring Regulation. I'm 100% sure our UK viewers are going to give us a correct answer. But let's go ahead and see how the community voted for this particular multi-choice quiz. Great stuff. The answers were almost divided, but the majority, 54%, say IET wiring regulation. So the BS 7671 is also known as the IET wiring regulation. There is a 26% that say British Power Standards. But is this though the correct answer? Let's go ahead and reveal. It is indeed the correct answer. But why is this the correct answer? Obviously, let's just go ahead and elaborate on the BS 7671. What does the regulations actually want from electrical installers? So basically, BS 7671, which is commonly known as IET wiring regulation, is basically the principal standard governing all electrical installations in the United Kingdom. So if you are dealing with panels like this standard is your friend. Okay, so setting out a requirement for the design, erections, and verifications of your electrical system to basically ensure safety and legal compliance. So the book basically covers a wide range of topics, including wiring methods, protective devices, earthing arrangement, inspection, testing, right? What's supposed to be tested and how it must be tested, and special locations such as bathrooms, hazardous areas. That's what the book covers. So in a nutshell, by providing such a standard, it's basically designed to maintain and prevent electric shocks and fires. So it's basically the same objectives with the National Electrical Code of the United States, which definitely only have one objective: to safeguard both the people and properties while aligning with the required legislation. Great stuff. So that is it, guys, for this CMTEQ Quiz review number 2. So make sure you check on the community tab where I release quizzes every now and then. And obviously you can catch up on the next review where we select the top rated quiz and review them together as we have done. If you found it useful, please make sure you thumbs up and subscribe to CMTEQ channel. That will be highly appreciated. Until next time, cheers.